Okay, there's a lot of math anxiety out there. It ranks right up there with snakes, public speaking, and heights. All the more reason to talk about math, teaching math, and some strategies that will help for all your students as well as students with disabilities. So, keep calm and love math. My name is John McMullen. This is my presentation on assessing and teaching mathematics. I've divided this into three parts. First part of a description and explanation of why I chose math. Secondly, considerations for teaching to students who have disabilities. And third, my three research-based strategies that target math skills for students with disabilities. All right, so part one, an explanation and description of why I chose this topic. It's a little personal to me. I am a math teacher. I am currently in the 8th grade teaching math in the regular ed classroom. This is my third year there, and I taught math for a year in the special ed classroom before that. So oddly enough, I like teaching math. This was an easy choice. I put this graphic up here because I think it reflects sort of the math classroom. It can be a bit of a roller coaster at times. You get some ups and downs, some highs, some lows. What I mean by that is I regularly am in the classroom where I'm teaching a difficult topic and I look out and even the most math inclined students look at me with confusion and dismay. And that's tough. They say, Mr. McMullen, we don't get it. We don't understand you. That's tough as a teacher. On the other hand, you persevere, you change your strategies, and all of a sudden you have a student or students that all of a sudden just get it and you can see it. It's almost like in a cartoon where the light bulb goes off over their head. And those highs, when a student gets it and can apply a concept to all the following problems, it is a beautiful thing. So you get some real highs and some lows. It's a little bit like riding a roller coaster, especially with the drama in 8th grade, but sort of like being in the eye of the hurricane. And that's what the math classroom can sort of be like once in a while. So what are we talking about? It's a broad range, all the way from basic facts to algebra. And I'm not going to get into all of those topics, but from elementary through middle school, we have a broad range of math topics that we're dealing with. I do want to address some of the pre-number skills because quite honestly, even as an 8th grade teacher, these were sort of new to me. I mean, I just take it for granted that students know these things. So this was a bit of a learning opportunity for me. These four were outlined in your text. One-to-one correspondence, matching one object with another object. We sort of take it for granted that they're going to go 1, 2, 3, 4, 5, and they're only going to count everything one time, but that's not automatic. And to develop an understanding of numeration and how to count, they have to know that you only count one object each time, 1 to 1, 2 to 2. And so one-to-one correspondence, very important concept. Classification, grouping objects based on common characteristics like color. It's important because they can start reducing large number of objects to more manageable groups. Seriation, much like classification, they're ordering objects based on attributes. It's a little more specific than classification. We're getting into length and weight. And again, it's important because they can start evaluating groups of items beyond very simple classifications. And then algebraic principles, you may not think about algebra and early elementary, but even at that age, we want students to start identifying patterns and relationships between numbers and objects. And this is all going to facilitate their problem-solving skills later on. So early number, pre-number skills, very important. Then as we get into later elementary and middle school, things that you probably, and I'm probably more familiar with, that we see more regularly, place value, the four basic operations, fractions, all kinds of measurements. These are the kind of things that students will start using to really solve problems in science and other classes. And ultimately, we're working towards problem solving. The ability to be confronted with with a complex problem and be able to solve those both in their academic life, their personal life, and ultimately in their professional life. So part 2, teaching students with disabilities. The text outlined 10 instructional methods that they recommend for teaching students with disabilities or students in RTI. I'm not going to speak to all of them. One of them is data-based decision making. This is using tools, progress monitoring tools, and two of the big names in the business, Ames Webb and STAR at my school. We happen to use STAR. We test all the students every 6 weeks because it's easy to go along and just go through the textbook and give your formative assessments and really not have that clear of an idea where how students are progressing either individually or relative to their peers. And so it's important to keep track of that progress. On the left side of this graphic, you'll see a great visual that I use all the time. It shows all my students in a class, and there's a line that reflects where we want them to be. And you can see the students that you have at or above the line and those below the line. And then on the right-hand side, for individual students, you can track their progress over the course of the year. This is important for two big reasons. First, it instructs our teaching. It's not just you got to use this information. You can't just give the test and then not do anything with it. If you see a pattern, students not understanding particular concepts, that means as a teacher, you need to go back and change things. Something is not effective and you need to change your lesson plans, change your instruction, until you see that reflected in your progress monitoring. On the right-hand side, students need to be motivated. They need feedback on how they are doing. And so I show students after all of their STAR tests how they do. I conference with them, and this is a real motivator for them. If they see that they're moving up, it encourages them. It gives them self-esteem. I've seen even the least math-inclined students that when their numbers go up dramatically, will jump in the air, will fist bump me, they will be motivated, they will be proud, and the next time they take the test, they're going to try hard, and they're going to try hard in class. Involving peers, the text discusses this in a few different ways. What I've seen in the classroom is students working with each other is extremely effective. After direct instruction, you turn it over to them, and it does a couple of things. One, it gets them talking, it gets them thinking out loud. They're coming up with ways to solve problems that I didn't even teach. And for some students that are struggling behaviorally, you see on the bottom support, it shows how students should work in the classroom. So it helps their math skills and it helps their behavior skills. Talking to parents, why? Because as I said at the outset, a lot of parents have math anxiety. They may not want to deal with math, and if it's not being discussed at home, the students aren't getting positive feedback, they're not practicing. So talk to your parents, tell them what you're doing in classroom. In some of my parent-teacher conferences, I have had students there with the parents, and for example, we might be working on scientific notation. Some of those problems just involve crazy big numbers, and we're calculating distances between stars, solar systems, and doing problems that quite honestly the parents would sit down and have no idea how to do. They look very intimidating, and their son or daughter can walk them through the problem. Not only will that sort of help the parents sort of understand things and be more willing to maybe work with them at home, it gives them a lot of pride. They're like, wow, my son or daughter can do problems like that? Unbelievable. So it accomplishes a couple of really effective things. Keep your parents informed. Teach to mastery, I'm going to talk to that in the research-based strategies part. Establish goals and monitor your progress. I discussed that earlier by using progress monitoring tools, and then use computer-assisted instruction. And that's going to be one of my research-based strategies as well, so I'll wait to get to that. So part 3, my research-based strategies. Number 1, this is a tried and true approach, going from the concrete to the representational to the abstract. So for example, in the graphic, you see teaching fractions, and you might start with tiles, then you would go to having them draw pictures, to finally, in the end, working with fractions numerically. And so as I've outlined on the side, concrete, you start with objects, manipulatives, and things they can touch, see, feel, move around. Then you go to the representational, and this involves them drawing pictures to help them work out problems. And then finally to the abstract, where they're actually just doing problems numerically. And I've done this, and I am doing this right now in a unit in 8th grade with transformations. You may not remember transformations from middle school, but it involves moving figures around. We started with drawing triangles, squares, and tracing them on transparencies with markers, moving them around on a piece of paper. Then we got rid of the transparencies. We were drawing them on a coordinate grid and moving them around. And now finally, we got rid of everything. They're solving all of them. They're moving figures and points around on a plane, simply using algebraic rules. Just great example. So it applies not to just students with disabilities, but all the kids in a classroom. Strategy number 2, computer-assisted instruction. I use a couple of computer apps, and first I've outlined the benefits from that, a wide range of experiences. Those computer apps can give them a lot of examples and illustrations to make a concept clear, just much more multidimensional than a teacher explaining it. It provides motivation through graphics and pictures. It gives them immediate feedback, sometimes hard to do in a regular classroom, where they do a problem and immediately tells them, are they right or wrong? Individualized instruction. Anybody who's been in a classroom knows it's hard for the teacher to get around to everybody. And so you've got fast learners, slow learners. If you can individualize that to each learner, you can really leverage your teaching ability in a classroom. And finally, interactive learning. A lot of those apps just have the students very engaged. They are doing things, they're moving things around, they're solving problems, they're playing games, and it also gives them immediate feedback. Strategy number 3, teaching to mastery. Again, a lot of these, it's interesting, they're universal. They're targeted towards students with disabilities, but it's so effective for all the students in your classroom. You want them mastering a skill before they go on, because a lot of those skills are cumulative, and they need to use one to do the next unit. So you want to have them master things, because they're just going to struggle in the next unit if they haven't mastered what you just taught them. But beyond that, mastering a concept does some great things for the student. It increases their self-esteem. And when we're dealing with math anxiety, that self-esteem is huge. It's so important. They start to believe in themselves. They believe they can learn new material. And when that happens, their confidence goes up, and they actually start looking forward to coming to class, being at school, and getting new assignments. Finally, the references. I relied heavily on our text, as well as some references from the internet. So just remember, stay calm and love math.